We have here an probability question from year 12 where we have two independent events A and B are such as probability of A is this one, probability of the union is 0.8. And they ask us to find the probability of B and the probability of the intersection. So we have our events here. Well, this is not a rectangle. And we have A and B, that they have something in common, so they have an intersection. Let's going to say this is A and this is B. And I know probability of A is 0.2. This is 0.2, but I don't know which number goes in each. And probability of the union is 0.8. So all this together is 0.8. If this is 0.2, that means the rest up to 0.8 is 0.2. So this is going to be 0.8 minus 0.2, which is 0.6. And as this is 0.8, outside I'm going to have 0.2. Although I think we are not going to need it, but this is what we know so far. I need to find the probability of B. So I need to find the whole thing. And I know the A and B are independent. So I know that the probability of A or B, so A or B all together, is going to be the probability of A plus the probability of B minus the probability of the intersection. Yeah, because I'm adding probability of A, probability of B, and I'm counting these twice, so I'm going to take away. And this is one formula that we are going to use in the future anyway. Probability of, this is union, sorry. I say union, I hope I did. A union B, so all these together. Probability of the union is given and is 0.8. Probability of A is 0.2. Probability of B, we need to find it. And we have probability of the intersection. But we know A and B are independent, so we know that the probability of the intersection is going to be the product of probability of A and probability of B. And probability of A is 0.2 and probability of B, we don't know. But we are going to be able to substitute this here. So we have an equation with just probability of B. So 0.8 is going to be 0.2 plus probability of B minus 0.2 probability of B. And when we solve this, we have 0.6 is 0.8 probability of B. So probability of B is 0.75, yeah, which is all this thing, 0.75. Yeah, so 0.5. We cannot complete, probability of B is this whole thing. So this is 0.6, that means this is 0.15, 0.15. And probability of A is 0.2, so if this is 0.15, this is going to be 0.05. So we have all the probabilities here. And then this is the first part of A. Second part is the intersection, probability of the intersection. So we have here is 0.15, but we can use this one here. So we have probability of the intersection is 0.2. Probability of B, which is 0.2, 0.75. So probability of the intersection from here, we know is 0.2. Probability of B, which is 0.75, so is 0.15. So this is probability of the intersection, this is probability of B. And then the last thing they ask is state with a reason whether or not the events A and B are mutually exclusive. To be mutually exclusive, remember they cannot have intersection. And I have intersection because I have a probability different than 0. So you can say something like that. The probability of the intersection is different than 0, so they are not mutually exclusive. And that's it. That's the question.